Hi there, and thanks for joining us today. We'll be talking a little bit about seismic forecasting and the seismic PISC monitoring period. The primary goal of this work is to develop an induced seismicity forecasting toolkit to reduce the seismic risks associated with carbon storage and improve the likelihood of project success. It will also engage the public and other stakeholders to garnish confidence in the overall project. These forecasts should be fast, they should be able to be produced and updated in near real time, and they should be easily digestible by end users. Additionally, they should apply to all periods of the operation, including before, during, and after an injection operation. In general, we will use combinations of historical seismicity, observed induced events, and operational procedures to produce something like an induced seismicity weather forecast. Information used to generate these forecasts can then be used to inform the duration of the seismic post-injection site care monitoring period. As an illustration of the forecasting toolkit, here we apply the methods to an induced sequence of earthquakes in Oklahoma, which are shown by the colored dots in the top panel. We use a geomechanical model to convert injection rates from all wells, shown by the triangles, to a Coulomb stressing rate, which is now shown in black on the bottom figure. We then use that information to drive the physics-based forecast, which is fit to a portion of the observed seismicity, which is here shown in red. The results of this fitting operation in a given training period are now designated as the blue portion of the curve, and the forecasting period is now shown as the red solid line. In general, we see that the physics-based model does a pretty good job of matching the total number of events that occurred in the sequence and the overall seismicity rate, but it failed to capture the transient changes in the seismicity rate that occurred at the times of the two swarms, shown by the bumps in the black line. If we apply another forecasting method, this time a statistical model, we can capture the timing of the seismicity rate transients, but not the amplitude. Our ultimate goal is to combine these models and several others to produce an ensemble forecast. As an example, once a forecast is produced, we can then test the impact of various mitigation strategies on the event rate and the associated event magnitudes as given in the example in the figure on the right. Our vision is to create a web-based interface that functions in different ways depending on the end user. For the general public, you will be able to open a web page that provides seismic and injection data gathered from public sources, like that shown in the top panel, and produces an ensemble forecast of the seismic hazard in some area that's shown in the middle panel and in the map on the right. Conversely, an operator may interact with the interface a bit differently. In this case, they would be allowed to upload a seismic catalog and injection or pressure data, modify the input model parameters, and then ultimately arrive at a seismic hazard forecast for their site or region. Additionally, this interface will provide operators with a set of response options to take in the event a seismic hazard exceeds some threshold. Finally, at the conclusion of an operation, we can use our preferred forecast to estimate the duration of the post-injection seismic activity based on both seismic and injection parameters. This information can be useful to a regulator seeking to impose a PISC monitoring period. In this example from the Oklahoma sequence, we see that earthquake activity is only projected to continue for about 6 months to 3.5 years, depending on the injection rates right before the operation was closed. These durations are considerably shorter than the 50-year PISC monitoring period currently imposed for leakage purposes, and they may suggest that a separate seismic PISC monitoring period be imposed. Thank you, and I look forward to answering any questions you may have.